All right, cool. Check it out. So, what we're going to do right now is we're going to look at degrees, minutes, and seconds and how that relates to the instruments that we'll be working with, like the theodolite or the total station. We can all agree this circle here, 360 degrees. When I'm doing layout, I'm trying to triangulate these squares within this circle. And I'm constantly trying to figure out the angle of interest that I need to turn my instrument. Conversion of measurements is going to be a commonplace in daily layout. We're always trying to convert a measurement over. There's two types of measurements that we use, degrees, minutes, and seconds, and degrees and decimal parts of a degree. Our instruments, like the theodolite and the total station, speak in degrees, minutes, and seconds. It's a far more accurate way to obtain line of sight. I think we can agree that if we look at 360 individual degrees, that's quite a few. But we can compound on that and speak to it as there's 60 minutes in between each individual degree. If I multiply 360 by 60 minutes, I end up with 21,600 individual lines of sight. And then if I go a little further and I multiply that by 60 seconds, with 60 seconds in between each minute, I end up with 1,296,000 individual lines of sight. We have increased the accuracy immensely there. So when I set up in the beginning, what I do is I would set up my instrument over a point of beginning, plumbing it up over that, and then I would shoot down along my control line here, and I would zero out my instrument on the backside. Some of the older instruments, like some of the older theodolites, may have a vernier scale on it. They're a little bit more difficult to use. Today's instruments, the digital theodolite has a digital readout on it. That is way far greater for accuracy. So real simple, I'm triangulating this structure off of my point of beginning. And what I'm trying to solve for here is the angle of interest. So when I do my triangle math, my run and my rise, and I solve my diagonal, there's another function there, this angle of interest, that I'm looking for so I can create line of sight with the instrument. So if we take our calculator and we open it up and we start and the first thing I like to do is I like to change some preferences about my calculator. What I want to do is turn it on. First thing I do is I go over and I hit convert store. What that does is it changes the preferences. If you're working with a Construction Master calculator, same function, convert store, and you should end up with something that says fractions. That's the preference your calculator is set at for tolerances. Continue to hit store until you come across DEG or 0.00. That will be your decimal degrees. In order to change that preference, you just hit the plus button. We're looking for float. So if you come up with float, the next thing you're going to want to do is just hit the clear button on your calculator, and that will set that as a preference. What that does is it will take the decimal degree out from the hundredths and take it all the way out to the hundred thousandths. This makes it more accurate, so when I go to convert it to degrees, minutes, and seconds, it'll be far greater accuracy. So if you're working with the tablet or the app, just go ahead and go down to your settings and you'll find decimal degrees and make sure that's on float. Once it is, we can get started. So we take a look at this here and we have some known preferences, right, or parameters. One being 7 foot off the baseline to our structure. That is this side of the triangle, the run. So we'll put that in our calculator as 7 foot run. And then the distance from our control line to the structure is 5 feet. So we'll call that the rise, 5 foot rise. And now I can hit diagonal next to the run button, and that will tell me this distance, 8'7¼ Important to record that number because if I'm working with a theodolite, I physically have to pull this distance from my point of beginning to this point of interest on my structure. The next piece of information I'm looking for is the pitch or the angle of interest. So if you go to the top left part of your calculator and you hit pitch, you should get a decimal degree, and you'll see it goes out to the 100,000. So that's that preference that we changed it to. You end up at 35.53768 degrees, and that's in decimal form. The instrument speaking in degrees, minutes, and seconds, I need that number, so I hit the convert button on the left side. And remember, anytime I'm hitting that convert button, I'm telling the calculator I want to do that second function. And if I look down here on the bottom at decimal, you'll see DMS to degree, hit that. And we end up with 35 degrees, 32 minutes, and 15 seconds. At that point, I would just rotate my instrument along that angle of interest, lock it in place, and shoot this corner right here. And I would proceed the rest of my layout doing triangle math to these corners, that corner, all pulled from my point of beginning. That's a real short gist of how we work with the degrees, minutes, and seconds and the instruments. Hopefully that was helpful. Happy shooting.